In this video, I'm going to go over solutions to problem set 5.1 from your book, starting on page 171 and looking at questions 1 through 6 found on that page. Question number 1 says when a sample of NH4SCN is mixed with solid BaOH2 times 8H2O in a glass beaker, the mixture changes to a liquid and the temperature drops sufficiently to freeze the beaker to the table. Which statement is true about the reaction? And your choices have to do with whether it's endothermic or exothermic and whether delta H is positive or negative. And since the temperature is dropping, that should clearly indicate to you that this is an endothermic reaction because energy is being absorbed by the system, so the surroundings are getting cooler. And that means that delta H is a positive value. And the correct answer then that matches that would be B. Number 2, which one of the following statements is true about all exothermic reactions? And the key here is that it has to be true of all. They produce gases, not always, sometimes, can happen, but doesn't have to happen. So that's not an always statement. B, they give out heat, or release, or liberate heat, however you want to say it. That's always true. C, occur quickly. Again, that's a sometimes. They can or they can't. Reaction rate has nothing to do whether it be exothermic or endothermic. And D, involve combustion. Well, combustion reactions are always exothermic. That's only one kind of exothermic, not all exothermic reactions. So if it said all combustion reactions are exothermic, that's true, but not all exothermic reactions are combustion. So B is the only statement that's true all of the time. Question number 3 says, if 500 joules of heat is added to 100 gram samples of each of the substances below, which will have the largest temperature increase? So we're talking about the MCAT equation, and we know delta H is going to be 500, and the mass is going to be 100. So the question is, do you want the largest C value or the smallest C value to give you the largest temperature increase? So it's either going to be A or D. It's either the biggest or the smallest, so we can eliminate B and C. So let's look at it. If 500 equals 100 times C times delta T, if I want delta T to be at its maximum, I need C to be at its minimum, because C times T times 100 is going to give me the 500. So that means I should be choosing gold, the smallest C value. Number 4 says the temperature of a 5 gram sample of copper increases from 27 to 29 degrees. So delta T is going to be 2. And they want you to calculate the heat added if the C value is 0.385. So using MCAT, I've got 5 times 0.385 times 2 degrees. And when you're doing this on paper 1 and don't have a calculator, what you should notice is 5 times 2 is going to be 10, so it's really 10 times 0.385, which is pretty straightforward math and gives you an answer of 3.85 joules, or letter D would be your correct choice. On number 5, they give you some C values again. I've got aluminum at 0.897. I've got beryllium at 1.82, CD at 0.231, and chromium at 0.449. And this is just a slight variation from number 3 because they tell you you have 1 kilogram samples of each one, so mass is constant for all of them. And they don't directly tell you that the heat is the same, but delta H is the same heater for 10 minutes. So whatever energy is put in is going to be consistent for all of them. So delta H equals MCAT. If I want to know which which metal is going to be the warmest, H and M are staying constant, so it's really the relationship between C and delta T. So when C decreases, delta T has to increase. So I am looking for the biggest temperature change, which would occur with the metal with the smallest C value, or letter C, the cadmium. In number 6, they're talking about mercury, and they tell you the C value is 0.138 for metallic mercury. If 100 joules of heat is added, so that's delta H, make sure you can read that, 100 joules of heat is added, and then the mass is 100 grams, they want to know what's the final temperature if the initial temperature is 25 degrees. And the way I'd recommend doing this is set up MCAT with temperature change in there and solve for temperature change. So that means I would have 100 joules equal to 100 grams times 0.138 equals delta T. So when I get delta T alone, I'm going to end up with 100 over 100 times 0.138 equals delta T. And so when I solve for delta T, that is a temperature change of 7.25 degrees Celsius. Now, it's not my final answer because that's just my temperature change, but they want to know what's the final temperature. And you have to read here, they say the heat was added. So if I take my initial temperature of 25 plus the 7.25, and I should have my zeros on here with my 25.0. So you see the sig figs would end up being 32.3 degrees Celsius.